So do you have any questions first prior to going? I mean, any doubts or something? I think I spoke to Ganesh yesterday. But yeah, Vijay, if you have any questions or something, just let me know, or we'll proceed with a new topic today. All right then.
No, sir. Yeah.
So the service that we are going to see today is called VPC. Okay. So I just want to understand what is your guys' understanding of basic networking, right? Like what is an IP address, right? Are you familiar with those type of things?
We know initially just a basic concepts of like
Okay. Do you know what is a private IP? What is a public IP? Right.
yeah, private IP is
Yeah.
yeah, go ahead, Jay. Yeah, private IP
So
is
the
something okay, go ahead, Jay.
Okay. So no problem. I will explain. Right. So IP addresses we have private, public, right? So if you are okay, if you know what is that, fine. But I will just explain at a high level because we need to know that with respect to VPC. Okay. So what is VPC? It stands for it is a service provided by AWS, and it is called Virtual Private Cloud. Okay. So simply put, you can think of it like your private network, right, in AWS or on AWS, whatever you want. Right? Private network means what? It is like your LAN in AWS. Right? It is like the local network inside AWS, because the previous service which we saw S3, it does not need any, what do you say? You don't need to create a network for it. It is online storage. You can just access it from anywhere. That is, you don't need to worry about the network uh, backend or the network backbone for it. But for almost every other service, you need a network, what do you say, backbone. You need a network, right? Suppose in your organization, right, in your company, right, you have your laptop or your computer on which you work, right? So it is connected to your office network, right? It is connected to your office LAN, which in turn is connected to the internet, right? They will have a router or something, right? And it is connected to the internet. And all the devices in your office might be connected to one LAN, right? Or they might have multiple LANs, or what we call VLANs or whatever, to segregate different teams and all that stuff. But all these machines, it's not only machines. You can have printers, right? You can have a database server, right? Other servers. All these, what do they need? They basically need an IP address, right? So they will be a part of a network, right? Either all part of a same network or into smaller networks called VLANs or whatever you call in the on-premises environment, right? So who takes care of all that? Usually the network team or the IT team, or depending on what size of a company you have. In small companies, it will be a single team that takes care of the networks and the servers. In bigger companies, you might have a separate network team and all that, right? So they create the LAN, and you just come in and plug in your laptop into the port or connect to the Wi-Fi, and you are connected to the office network, and you can connect to the resources inside the office network as well as go to the outside world, right? So now what we are doing, instead of using on-premises, we are shifting to AWS, right? What are we shifting to AWS? Are servers and server services, all that stuff. So a lot of them need an IP address, right? They need the networking. So here in AWS, we call it the VPC. The service is called the VPC, right? And what is a VPC? It is a private network inside AWS. So you come in to AWS and you create a VPC, right? So this VPC is like your LAN, right? So the other services except S3, right? S3 will not be in a VPC because it does not, you don't control the networking for S3, right? So VPC is like your private network inside AWS. So when you create a server, it will be inside the VPC. When you create a database server or application server or whatever it is, it will be inside a VPC, right? So a lot of other services also need the networking, so they use VPC, right? So say for example, somebody says I have a server in AWS, right? They will say I have a server in AWS, whatever server it is, Tomcat or whatever. So where is that server actually located in AWS, right? So if I ask you, where do you stay? Suppose I am asking Ganesh, where do you stay? What is your answer? Yeah.
I stay at house.
Yeah. So normally you will say I am from Bangalore, but technically where are you? In Bangalore, you are in some area, right? You are in some apartment and some flat number, right? Say 101. So even though you say I stay in Bangalore or I stay in some apartment XYZ, you are actually physically living in a single flat. You are not living in entire Bangalore. So same thing when we say we have a server in AWS, where is it actually located? It is located in some region, right? You can choose the region. We saw which region are you going to choose. Suppose you are going to create a Tomcat server in AWS. So where are you going to put it? Okay, in AWS. Which region, right? Then which VPC, right? Inside the VPC you have something called a subnet, right? Inside that is where your instances with the IP address. Right? So we are going to see all these things, right? So the infrastructure which you create will be actually inside a VPC, right? The servers, databases, and other things, right? They will be inside a VPC and inside a subnet, right? We will see what is VPC, what is subnet, but this is the basic high level, right? So it is the networking layer in AWS for your infrastructure. Anything that needs a IP addressing or yeah. So we need to create this VPC and use it. So before going into this VPC as such, we will just talk about some general, what do you say, networking background. Because all this is same whether you do it, I mean, the networking part is same outside AWS or anywhere, right? Okay, so you need to understand what is an IP address, right? I'm sure we all know what is an IP address and what is what is a private IP address, what is a public IP address, basically. And when we are talking about IP addresses, we are talking about IPv4, which we all know, which will look something like 192.168.0.1 or something. We are not going to go to IPv6. IPv6 and all that comes in core networking, and for that you need to know IPv6 and all that stuff. I'm pretty sure most of them don't know what is IPv6 or don't use IPv6, but some are using, right? IPv6 is not new or anything, it has been there for a long time, but still it has not been adopted. Okay? It is just how the IP is represented or how many bits it is, right? So IPv4, it is a 32-bit address. Maybe in engineering or something, in communications or whatever, if you are from electronics or computer science background, you might have learned about this, right? IPv4 is a 32-bit address, so it will look something like this. 32-bit. So what we are seeing is the decimal notation. 32-bit is, it's the binary. So how it is 32-bit? So each of this, right, separated by a dot, right, is called a octet, right? Octet means 8 bits, something like this, right? Dot. Sorry, dot, right? Like this you have, right? 8 you have, 8 bits in each octet. Right, and the value for this will be like 1, 2, 4, 8, 16, 32, 64, 128. So what is the IP address? What are the possible numbers that you will see in an IP address in IPv4? It will be anything between 0000 to 255, 255, 255, 255, and everything in between. Right? In IPv4, you will not see anything like 256 or 300, right, in an IP address. In IPv4. Why you don't see that? Because if you look at this, if you add up all these things, you will get 255. If you add up this, right, the value of each bit, right, you will get 255. Okay. To understand this easier, or by using the VPC, it is recommended to use these calculators. Right. One is called subnetcalculator.com, which is what AWS recommends us to use it, so that the networking part becomes, what you say, it makes our job easier, because everybody might not be from core networking background. Again, like I said, you may never create the VPC. Somebody else, if you're in a big company, probably then the network team is going to create the VPC. But if you need to create the VPC, you should know how to do it. Right? You can use the subnet calculator. You can bookmark this link. I will ping it in the chat. Please bookmark this link, because in the exam also you get a lot of questions on VPC. Right? And then you can also use this called CIDR.xyz. This is just to what do you say, to help you understand IP addressing and to create the VPCs, right? So what is this thing, right? So like I told you, any IP address you put here, you can visualize it in the binary format, right? So here you see there are 4 octets: 10, 88, 135, 144. So how do you represent 144? Now let us say, how do you represent 10? So the bit number 8 and the bit number 2 will be 1. If you add it, it will come to 10. Right? If this number has to be 10, then this bit has to be 1 and this bit has to be 1. So you can get any number between 0 and 255 by adding 2 or more numbers. Right? If you want 3, then 2 and 1 will be 1, 1. Right? So if you want 11, then you will have 8 will be 1, 2 will be 1, 2 will be 1. So like that, any number between 2 and 255 you can get by adding, what do you say, multiple. That is, multiple bits will be 1. So if you want 255 everything, then all bits are 1. Right, which is why your number is only between 0 and 255. It's a 32-bit address. That is 8 bits each, right? 8 into 4, 32 bit. Right, which is what is shown over here visually. Right, we put 15 over here, then these 4 bits are 1. Okay. Right, so this is just basic of IP address, IPv4. Okay, so the entire IPv4 range is this, right, and the combinations in between 00002 552. This is the entire IPv4 range. Okay, so now this entire range is categorized into 2 types: private IPs and public IPs. Right, this range is split up into segments or parts called private IP and public IP. Who defines these? They have some standards. It is not AWS standard or Azure standard. It is the networking standard, which is, what you say, I think it is by IANA or IATA, right? They are organizations which manage all these things. They will say which is a private, which is a public, what is IP, right? That there should be some standards so that everybody has to follow those standards, right? So this entire IPv4 segment, right, is split up into 2 major segments called private and public. So some numbers, that is some IPs, are categorized as private, everything else is public, right, at the basic level. So any IP in this range, that is 10.0.0.0 to 10.255, 255, 255, 172.16.0.0 to 172.31, 55, 55, and 192.168.0.0 to 192.168.55, 255, sorry, 192.168.0.0 to 0.2. No, I think 255, sorry. let us go here and say private IP addresses. Okay, and open any link, right? We are talking about IP before, right? So here you see this is defined by the IANA, right? This is the organization which dictates which IP range is used for what, right? So they say that 10.00 to 55, right, all the way to 255, 172.16.002, 172.31 to 55, and 192.168.002, 192.168. These are the private IP address ranges. If you are creating a private network, you should use IPs in this range, right? If you are creating a private network means what? Like your LAN in your office, right? Or at your home, you are creating a network, right? So if you look at your home router, right? At home also you have a network, I assume, right? You have a Wi-Fi router, right? So what happens is, if you look at your laptop's IP, it will be something like 192.168.1.100 or something. The router's IP will be 192.168, probably 1.1, because 192.168 is the most common range that these home routers use by default. They can use anything, and you can change this value to any of these other ranges if you want, but the default that it comes with will be in the 192.168 range, right? So all your machines will get IP in that range, that is 192.168 1.101. But if you go to your office, they might not use 192, they might use something like 10 dot or 172 dot, right? So by looking at an IP, you should be able to say whether it is a private or a public. How will you know? If it falls within this range, then it is private. Anything else is public. Everything else is public IP, right? So private IPs you can create and use. It is like, you can think of it like the extensions in your company, inside your office, right? Inside your office, there will be many people working, right? Each team might have their own extension, or each person might have their own extension, right? They are all private numbers. They don't need to contact Airtel or anybody. They can put whatever extensions they want, right? Your number is 100, 101, 102, internal extensions, right? Another office building. My office also, we can also have the same extensions, right? But if I dial 102, it will go to the other person in my office. It will not go to the person in your office, because these are private, right? So those are private IPs. You can choose any range which you want inside your private network, whether it is at home or outside network or AWS. The concept is the same, right? The private IPs are standard in the network. Okay. Okay. So the private IPs are used inside the LAN. The public IPs are used whenever you require to send traffic outside to the internet. So at your home, what you have a router, right? And then you have your devices connected, your laptops, your desktop, your phone, and all that stuff, right? So the router, the one side, right? The side over here is your LAN or wireless LAN. That is, it is your private network. Whatever is here is your private network. So if you buy a router and simply connect only the devices, then what will happen? These devices can talk to each other, file sharing or whatever you want to do. You can create a DB server over here, you can connect to it, right? Why you are able to connect? Because they are in the same network, right? But if you need to go to the outside world, that is the internet, then what you need, just if you buy the router and connect it, it will not go to the internet, right? You need a ISP connection. That is, you need a public IP, which is the WAN side, right? Where you need a public IP which comes from your ISP, right? So one side of the router is connected to the WAN side, the other side is connected to the LAN, which is why you are able to do both. What you say, connect to other devices within your LAN as well as go to the internet, right? So you need a public IP if you need to access the internet. That is provided by your ISP. It might be static, or it might change every time you reboot the router or something. The IP will change, but there is a public IP. If you're accessing the internet, there is a public IP somewhere, right? So you cannot just put whatever public IP you want. Public IP is assigned by your ISP. Just like how you cannot go to Airtel and say, give me phone number 12345, they will not give you. They will give you whatever numbers they have available. If you want to choose a specific number, they will give you a list of numbers. These are the numbers we have. You can pick some number from that, or you can take whatever we give. Right? Public IP, you cannot say I want so and so IP, because somebody else might be using that IP. Right? Private IPs, like I said, two networks can have the same private IPs because they don't come out to the internet. They are inside. Right? So your laptop will have a private IP. If it needs to come outside to the internet, then it will use the public IP provided by your ISP. Right? If your device needs to come out, then you will put a router or something. Right? Your traffic goes like this. Right? So the private IPs are not routable over the internet. They are only for internal communication. If you need to come out to the internet, then you need a public IP from your ISP. In AWS's case, AWS will be the ISP. They will provide you with the public IP. Okay. So the next thing is, how do you represent IPs? Right? We know what is the IP range, right? So how do you represent an IP in a CIDR notation? So in college or school, you might have learned of class A, class B, class C, right? IP addresses. The same thing again, people will say class A is, this is class A, this is class B, this is class C, and then you have class D, right? So, but in practical networking, we don't use classes anymore, right? We use CIDR, that is classless interdomain routing. This is general networking. This has nothing to do with AWS. It applies in AWS also, right? We use classless interdomain routing. So you should not say class A, class B, all that. It does not matter anymore these days, right? Maybe 15-20 years ago, people were talking about class A, class B, but now it is not there, right? I mean, but theoretically it is there, but we don't follow that style of representation anymore. We use the CIDR notation. So what is that? So you will see something like 10.0.0/8. So this thing, right? The first thing, I can represent it like this: 10.0.0/8. What is the meaning of this, right? So we call this slash, right? The number that comes after the slash as the net mask. So by using this notation, I can get the different values for my network. So basically, your IP address, right? It will have two parts. That is the network part and the host part, right? So what do we mean by this? Simple example is, now let us say you need 100 machines in your network, 100 devices in your network. So what is required? You need to have minimum 100 IPs, because two devices cannot have the same IP, right? There are going to be 100 machines in your network, whether it is a server or a printer or something which needs an IP, right? You need 100 unique IPs, right? So you need to have 100 IPs, right? So these machines or devices are called the hosts. So when you are creating a network, you should make sure that you have enough IPs, because you can create a small network or a big network. It is up to you, right? But you have to create a network where the number of devices you put, everything is able to get a unique IP. So you should not create a small network or a big network. So how do you know whether it's a small network or a big network? Big network means the hosts will be more. I mean, you can have more hosts. Small network means the number of hosts will be less. So how do you know small network, big network, all that? By looking at this notation, you can say, right? Suppose it is 10.0.0/8. It means that the first octet is constant. The last three can change between 255, 255, 255, which means you can have 65,536 IPs. How I know this? I know this because I worked in networking earlier, but I will show you how you can calculate all these things, right? Using that calculators, right? So if I say something like one, so at your home it is probably 192.168. What do you say? 0 dot, or probably it is, yeah, it should be 1.0/8. 24. What this means is the devices in your network will get an IP between 192.168.1.0 to 192.168.0.1.255. That is,
Siddharth, what is this 24 actually?
yeah, I'm coming to that, right? So this 24 is, so I told each is 8-bit, right? So 24 means you can think of it as these 3 bits are constant. That is, these 3 numbers will remain the same. The last number will change between 0 and 255. That means you can have 256 IPs. So at your home network, you can represent it like this: 192.168.1.0/24. That means your devices sitting behind the router will get an IP between 0 and 255. Obviously, they will not get 0 and 255 because 0 is the network address, 255 is the broadcast address. So your devices will have an IP between 1 and 254. That is, practically you can connect 254 machines to the network at your home. You cannot connect 256 or 257, 258 because there are sufficient IPs are not there. If you want to increase the number of IPs, then you need to decrease this number. This is called the net mask, right? So by looking at this CIDR notation, I can give you all that information. What is the network address? Here the network address will be something like 192.168.1.0. The host is anything between 0 and 255, right? That is, you can have 256 hosts on paper, but practically the first and the last IP you cannot use because the first is the network address, the last is the broadcast address. In between IPs you can assign to your hosts. Hosts means your machines or whatever that needs an IP. So for this you use this calculator called subnet calculator, CIDR or CIDR.xyz. So when you are creating a network, you should know how many devices are going to be there in it, or in future how many might come in your private network, right? So at your home you can use 254 because they know that most of the people will not have more than 15-20 devices in the home network, which is why they create the router by default as 192.168.1.0/24 or something like it has a /24 network, right? If you want more, you can I don't think you can do it on your home router, but in other places you can do, right? The home routers are fixed at /24. You cannot, most of them you can't change, at least the basic ones. More expensive ones maybe you can change, but the basic ones you can't change. But otherwise in networking you can create your LAN as small or as big as you want. So how do you do that? So you have to know that these are the only 3 IP ranges you can use. These can be represented in the CIDR like this, right? 10.0.0.0, right? So this is called what? It's called this, right? You see it is represented as 10.0.0.0/8. Both mean the same. Either I put this big number or I put this small number, it is the same, right? 172.16.0.0, 172.31.255 is represented as 172.16.0.0/12, and 192.168, this entire range is represented as /16. Okay, the smaller this number after the slash, the bigger the network. That is, the more number of hosts you can have, right? The smaller.
So Siddharth, once just a pause. So when you say about like 8, 12, 16, okay, so you should come from left to right, right?
Yes. Like,
Since it is 12, right? So it is 8 plus 4, so that's 16. That's why.
yes.
Is it so?
Yes. Right. It comes
Okay,
like this.
okay.
So I'll show you in the calculator. When I show you, it will be clear, right? So the main thing is the smaller this number after the slash, the bigger the network. That is, the more IPs you can have. That is, the more hosts is possible to have, right? In the 192 range, you can have only 65,536 IPs because it is a /16 network. /12 is so many. /8 is so many. Okay, so it can be any number. It does not have to be 8, 12, 16. It can be 8, 9, 10, 11, 12, anything between 0 and uh, 32. Practically, not practically, theoretically on paper. The slash can be anything between 0 to 32, right? The bigger the number, the smaller the network. right? Okay, so how do you know that? We use this calculator. If you are not into core networking, so using this calculator, make sure you are at CIDR. Don't go to subnets, go to CIDR, right? The link which I gave you, go to CIDR and you enter the IP address range. Suppose now you want to create a network. Now say you are going to have 200 machines, right? And say you have to choose the private range because we are creating the private network. We are not managing the public network, right? So you can choose whatever range you want, right? Like I said, at your home, you get 192.168. In your office, you may not want to use 192. Maybe you want to use this, right? So you choose the IP that you want to use. Like say I want 10.0.0.0, and then I want 200 IPs approximately. Let us say in my LAN, I'm going to have approximately 200 devices, printers, servers, employees, computers, all that stuff. So I need 200 addresses. So in this calculator, basically you need to enter two values, any two values. The other things are calculated for you, right? Basically, this value you will enter because you have to choose what IP address range you want to use. So I want to use the 10.0.0. It is a valid private IP address range. And then how many addresses I want. So you cannot put exactly 200. It will be in certain multiples, right? You have to choose the closest multiple. Suppose you need 200 IPs, you should not choose 126. If you choose 126, what happens? Your network is defined like this: 10.0.0/25. And what is the IP address range? It is going to be 10.0.0.0 to 10.0.127. That is, these three remain constant. This last number will change only between 0 and 127, right? Because it is /25, right? It is /25. So if you look at the calculation, right, this number, right, 25 means what? 1, 2, 3, 4, right? 8 3s are 24 plus 1, 25. So till here it is constant. Only this last combination can change. Last combination can change between what? If you add all the numbers, it will come to 127, right? The last number is 128. If you add that, you get 255, right? Now you get it, how it is calculated, right? Because IP addresses are actually binary. We use the decimal so that it is easier for us to, what do you say, remember the numbers, right? So it goes from, like you said, from left to right, right? The values I showed you, right? Each octet is 1, 2, 4, 8, 16, 32, 64, and 128. So when you add those numbers, you will get 255 or anything in between, right? So when I say 10.0.0/25, if you are in networking, you will know it. I mean, if you do it enough times, you will get the hang of it. But you can use this calculator, right? You can either put the maximum IP addresses, which is what will be easier for beginners, or you can put the mask bit. If I say /24 or I say /25, it will automatically calculate the other values. If I say /25, that means the maximum addresses are 126. And what are the possible addresses? The range is this. That is, the first three are constant and the last number will be only between 0 and 127. It cannot be 128. Because only the last 7 bits are 1, right? The first 25 bits are constant, right? So now we want 200 IPs. So what you can choose? You can choose maybe 254. Because if you put 126, then you cannot have more than 126 devices, right? So if I put 254, then what are the IP? What is the CIDR notation? It will be 10.0.0/24. So if you see 10.0.0/24, then it means that the first three octets are constant, right? 24 means 888. That is the first three. The last number will change between 0 and 255, right? The last octet will change between 0 and 255. That is, you can have technically 256 IPs, but they will say 254 because the first and the last IP you can't use, right? 0 and 255 can't be assigned to your device. 0 is the network address and 255 is the broadcast address. So
if it is so if it is /26 means then,
yeah, so the smaller the bigger the number, smaller the network. If you say /26 is the mask, right? If you say /26, then you can have only 62 addresses.
okay, so how it calculated here in the CIDR address
Same
range?
calculation.
So 8 is a 24. First three won't change. Okay.
Yeah, so first three will anyway remain constant. But why the last is going only between 0 and 63? Because these two bits will be 1. If you add these other numbers, what you will get? 1 plus 2 plus 4 plus 8 plus 16 plus 32. You will get 63. Right. Right. So each octet is, right, you have 8 bits. Right. I'm just putting everything as 0 for now. 3, 4, 5, 6, 7, 8. Right. So the first bit's value is 1, second is 2, 4, 8, 16, 32, 64, 128. So now what we are saying it is slash 26. Slash 26 means till here 24, right? The first three octets, okay. And this octet, the two numbers, these two. So this is the network address. This part will be, you can think of it like the network. These are the possible hosts. You add all these, how much you will get? Right? 32 plus 16 plus 8 plus 4 plus 2 plus 1. How much you got? 63. Okay? That's how it is calculated. It will never go wrong. Right? So don't worry about this, why the number of IPs is showing less, because like I said, practically it will show a lower number because certain numbers you cannot use. Okay? Certain numbers we cannot use. So here it is saying 63, right? 63 plus is actually 64 because we are not including 0, right? So it is actually 64 on paper, but practically it is 62. If you add, you will get 63 because we are not considering 0, right? 0 means everything is 0, right? So 0 is the network address, right? So that's how it is calculated, right? In this CIDR calculator, it will say, right, 62. That is 64 minus 2, right? Okay. So we have to know how many devices we are going to have because the private network is in your control, right? So you should make sure you have sufficient IPs. Don't create something that is too small or something that is too big. Too big is also a problem. Not in performance wise. You cannot reuse those numbers elsewhere, right? So you should create something that is optimum. If you need 200, maybe you can go to 254. So that, assuming some future expansion, or okay, you think I'm going to expand more in the future, then you can create with 510. You cannot put 400 or something like that because that calculation is not possible, right? The mask bit can be only between 1 to 32, right? You cannot have just the exact number of IPs which you want. It has to be in these multiples. Mostly it will be plus or minus. Mostly you should choose excess. You should not choose less, obviously, right? So if you need 200 IPs, you can go to 54 or 510. Don't go to 1022 to 2046 because you are unnecessarily, you are blocking the IPs. If you don't use, if you create 510 and you are using only 200, then 300 IPs are simply lying there. You can use them, right? But tomorrow in your office they need to create another network, another private network. Then it should not overlap with the other network. Then there will be a problem, right? Suppose say you have a phone EPBX system or something which supports 100 extensions, right? You have a phone EPBX system which supports 100 extension numbers it can have. So you should not put all the 100 in one group or something like that, right? So maybe you have a feature where you can split them up. So maybe at present there are only 50 employees in your office, or your office has two groups of people, right? 50 employees and some 20 people in the management. So you can assign like say 60 or 70 over here and 30 over here. So the management have their own extensions, employees have their own extensions. So if you put all the 100 here, then everybody will be part of the same exchange or same network. But so when we talk about in what you say, practical networking, you want to keep the private networks different for different stuff, right? So in AWS, normally what we have, so how many VPCs we are going to create, how many LANs we are going to create, how many right private networks we are going to create, right? So VPC is the private network. So the next question is how many VPCs we are going to have, right? So in real time, what we do is in AWS, what are you doing? You are going to host something. I told you, right? Some application or some data, right? So normally, if you take any what you say environment, right? Any what you say infrastructure or company, right? They will have different environments. What are the environments? You will see something like dev environment, right? Staging environment or test environment and production environment, right? These are basically the three environments you will see plus or minus, right? So in AWS, how do you put this? Or in real time, outside AWS, how do they do? So probably they will have a separate LAN for dev, a separate LAN for staging, prod, and they will interconnect them because you want to isolate the stuff. You don't want to put everything in the one single big network. It is not a good practice. You can put, it will work, but it is not a good practice, right? So if you build a house, you will have a separate section for each of the stuff, right? For sleeping, you have bedroom, for watching TV, hall, right? For cooking, kitchen. You are not going to put everything in one big room and live, right? You can live, but it is not organized. It is not well organized, right? Same concept for the networking. So you want to divide your networks into similar stuff, into modular structures, because the people working in the dev, they will not work in prod. The developers, they need access only to the dev environment. The testing team and maybe some developers need access to the staging environment. The production environment, they will not come. If everything is okay, we as what you say DevOps or whatever IT admin, we will move that what you say that application or the changes to production, right? So there are different groups of people who are accessing different environments. Nobody is going to access all three. Maybe some people access all three, right? So you want to segregate the similar stuff into individual groups. So if you take in real time, right, how many VPCs you create, usually there will be one VPC for each environment, at least, right? So they will say something like dev VPC, staging VPC, and prod VPC. There are three VPCs, that is three private networks inside AWS in the same region. It is not that one region has to have one VPC. One region can have any number of VPCs that you want, right? So however you want to arrange your private network. Do you want to put all the stuff in one network, one VPC, or segregate into different stuff? This is how practically, right? So the dev environment, we will have a dev VPC, staging environment, staging VPC, production VPC. So maybe for the dev we use, so maybe in the dev I have only 100 machines, right? The developers machines, the development server, development DB server. Let us say altogether I have 100. So I can create the dev VPC something like 192.168, say 0.0 slash. What can we do? We can put 25, right? You look at the calculator. So this is where the calculator is useful, right? So you want 100. So maybe you will choose something close to 100. 100 you know for sure. So a little more you want to give. So tomorrow another machine or two comes, you have space.
Siddharth, I have a question here. Siddharth.
Yeah.
So here, when you say this, no, go to that one URL.
Yeah.
So yeah, so the mask bits will be maximum 32, right here.
Yes.
Okay. So based on that, 32 means like it can be 255 plus 255 plus 255 to 4 It can be in the maximum IP address, right?
32 means, I told you, bigger the number, smaller the network, smaller the host. 32 means only one IP. So that is what I'm coming to next. If you see /32, that means it is that particular IP. So in the network configuration usually, right, in the network engineering side, right, if you see something like this, right, so if I ask you what is your laptop's IP, what will you tell me? Can you tell me what is your laptop's IP?
One second.
You put IP config and you tell, right? Just tell me that IP.
Yeah. Sure, 1 second. So it's 192.168.1.100.
Okay. So you should not say like this in the networking world. You should say 192.168.1.100/32. So if you want to represent a single IP, it is represented as /32. That is
So how to say it's a single IP actually?
because all the bits they don't change, right? It is fixed. Your IP address is fixed. You understand?
Okay, okay.
If you want to
Mhm.
represent a single IP, it is represented as the IP/32.
Okay, okay. IP basically okay.
Right? If you want to represent one IP, it is that IP/32. If you see anything like IP/32, that means they are referring to this IP.
Mhm.
Because all the bits are constant, right? They don't change. Your IP is fixed. You have 1.100,
Correct.
it is 1.100. Tomorrow you might get 101, but you have only one IP. So it is /32. /32 means you are representing a particular IP. So in networking side, whenever you see /32, it means what we generally call as this IP, right? Everything else is a range. Any other number you put other than 32, right? It will have more than one IP. If you say 31, the maximum possibles are 2, 0 and 1, right? It is a range. It's a small range, but it is still a range, right? So if you go to 29, you will have more IPs. That is 0 to 15. That is totally 16 on paper, but 2 you cannot use for the devices. So 14, right? So the smaller this number, the bigger the network. That is, right? The smaller this number, the bigger the network. Big network means more addresses, right? So we need 100 machines. So I will create something like 192.168/.25. So this is going to be my CIDR for the network. This is the CIDR for the network. I am creating this network. So what is the meaning of this? In this network, I can have IPs from 1 to 126 or something, right? /25 is, right? 0 to 127, right? 0 to 127. So you cannot use 0 and 127. So practically, I can have 1 to 126. I need only 100. I have 26 extra, no problem, right? So, but now say I want staging. So staging I can create in 192 or I can create 172, whatever you want, right? But here if I create something big, suppose I say 192.168.00/16, then what happens? 192.168. Let us use 192 itself. 192.168. Yeah. 0.0/16. If I say that is, I'm using the entire 192 range, right? So the maximum is 65,535. Right? The maximum IP is 65,536 IPs. But I need only 100. You can create more, no problem. That IPs are going to be unused because it is free. All this is free. VPC is free. IP addresses, private IP addresses are free. There is no cost anywhere, right? So if you create this, then this VPC will have this network. This private network will have 65,536. So when I come here, I can also I can use 192.168.0.0/16. Here also I can create 192.168.0.0/16. But what is the problem? Tomorrow if you try to interconnect these two, it will not work because there is an overlap in the IPs. If you are not overlapping them, fine. If you are going to keep them separate always, then you can have multiple VPCs or multiple LANs with the same IP address ranges, right? Like I said, if you have two office buildings, right, both of them can use 100 to 1110 extension. Here also you can use 100 to 1110, but you can't interconnect both these, right? Because there is an overlap in the numbers, right? If you dial 100, will it go here or will it go there? You can't. So you need to have some other unique numbers over here. You need to have, maybe it needs to start from 111 to 120. Then you can interconnect, right? So if you have only a total of 100 extensions and you put all the 100 over here, right, 100 to 200, then for the other building, you cannot use the same numbers. If you use, it will be isolated. You cannot interconnect both of them. But for practical purposes, you need to interconnect your environments, right? the dev, staging and production will be interconnected to one another, right? Because you need to move your data from dev to staging, then from staging to production. So they will be connected. So you cannot use 192.168.0.16 over here because the entire range is used here. So maybe here you can use 10.0.0 range, right? And here maybe you can use 172 range because there will not be any overlap because the number, the what do you say, the class itself is different. So to avoid these things, right, don't create a network that is too big, right? So in your office, it might be required that all networks use 192.168. So your office, so you will see the dev, staging, production all use 192.168. That is, the first two numbers will be 192.168 for everything maybe. So maybe let us say you have only say 25 machines here, 25 machines here, and 50 machines here. So this entire thing, the total how much is coming to 100 total machines. So all your three networks put together, they are using only 100 IPs. 100 means, let us say, according to future expansion, maybe it goes to 254. So you don't need to create a very big network for any one single thing. So you can use the 192 range. What is the 192 range? It is 192.168.0.0/16, right? The private IP address range for the 192 is 192.168.0.0/16. This is the maximum size. You cannot go beyond this. If you go beyond this, it becomes a public IP. If it goes to 15, then some of them are public IPs because the private IP is only between these two ranges, 0.02 to 255. So if you see 192.168, it is not a private. If you see 192.168.0.0.2 to 55, within that range, it is private. If you see some number like 192.168, what do you say? Yeah, sorry, the entire 192 range, 192.168 is private. I'm talking about the other ranges. Because if somebody, they will see 172, they will say it is a private IP. No, it is a private IP only if it is between 16 and 31. If you see 172.14.0 means it is a public IP. Same thing, if you see 172.32 dot something means it is a public IP. It is not a private IP. Only this 192.168 is private. If you see 192.154, it is a public IP. It is not private IP. Only if it is 192 and 168, the other two can be anything. It is a private IP. So don't just see the first number and say it is private. That is only true in the first one. That is the 10 range. Anything that begins with the 10 is a private IP because the last three octets can change. The first is always 10. Right? But for 172 and 192, it is only 192.168 range which is private. 192.155, 192.167, 192.169, all those are public IPs. Okay. Okay. So we should not create a network that is too big because if there is a overlap, then you cannot interconnect the network. So if you need only 25 IPs and you want to use 192.168 for all the networks, you can use. You should just create a smaller network, right? You can say 192.168.0.0/ what? You can choose by maybe based on IPs, number of IPs, right? So you can say 30. That is the first one can be 192.168.0.0/27. Right? The second one maybe you can say 192.168 1.0/ whatever. Say you want 60 IPs over there, right? So you can say 192.168 1.0/26. Is it /26? So here, what is the range for the first one? Right? We said 192.168 0.0/ sorry, I said 30 for this, right? So it is /27. So what are the IPs? You have that range is also given over here, right? So you just have to get the hang of that calculator, right? So in my dev VPC, the IP address range will be from 00 to 31. I need only 25 IPs. So I'm giving this range 192.168.0.0/27. So the IP will be 0.0 to 0.31. That is between 0 to 31 minus 2. Say 29, you need 25, you have 4 extra, right? I'm using 192 range, right? It is well within our, this range, right? For the staging, I'm using 192.168.1.0/26. 1.0. So maybe I have more machines over there. I have 62. I will choose 62. So it will be /26. So it will be 192.168.1.0/26. What does that mean? This is the IP range for that network. Just put that over here. Just copy paste. Right. So for this network, for the staging, the IP address range will be 192.168.1.0 to 1.63. So there is no overlap between both these, right? Here all the IPs will be 0 dot something. Here all the IPs will be 1 dot something. So they are unique. There is no overlap between both these two, but both are using 192.168. But we are playing with the last two things, right? You are creating small networks. Here I can have, say, practically 30 IPs or something, right? Here I can have 62 IPs. Here I need 50 IPs. So here also I can create something with 62 IPs, right? Something with /26. But I should not say 1.0/26. If I say 1.0/26, what happens? Then here also the same IP range, so there will be overlap. So you should not say 1.0. Maybe you can say 2.0, right? You can say instead of 1.0, you can change it to 2.0. You will have the same 62 IPs, but in a different range. But in a different range, right? But in a different range. Okay. So instead of all the IP address, if you want to think of it as simple binary numbers, it is like you are instead of this IP addressing, if you want to look at it like a decimal number thing, right? Simply put, in this 192.168 range, you have 65,000 IPs, right? 65,000. Let us just take some number, right? So what you are doing is you are splitting up the 65,000 into smaller segments. That is what we are doing, right? So you can put the entire 65,000 as one big private network. That we don't want. We want a separate network for dev staging, but everything should be in this range, in 192.168 range. So I am splitting this into 32, 64, 64, something like that. I have some excess. I can use that in future. I'm not using it. If you use up that excess also, then future networks you will not be able to create. So don't create something that is too big or too less. Okay. So we are basically doing this, right? Maybe with a smaller number, maybe I can explain, right? Suppose you want, you have 255 usable IPs, that is 1 to 255. So what I'm doing is I'm saying 1 to 100 use for this network, 101 to 200 use for this network, 201 to 255 use for the other network, right? So it should not be overlap. You should not have 1 to 100 here, 1 to 100 here. If you have like that, both the networks will work independently. You cannot interconnect them because you cannot have an overlap when you interconnect networks, right? Okay, so we are managing the private network. The public network you can't manage, that is managed by your ISP. That is not our headache. So they also use these calculators, right? On the public side, we are worried about the private network because that's what we have control over. Okay, So you can choose like this depending upon your requirement. So the main thing is you should have your requirement. What VPC I should use? So the rule is you can only use those 3 ranges. You can choose any range you want. Some ranges have more IPs. If people need more IPs, they are going to use the different range, or they already have some range somewhere else. Now let us say people are already have one AWS account, right? In this AWS account, maybe they are using the 192.168 range, right? Like how we did. Now tomorrow they might create another AWS account. So here which range they will use? Here also they can use 192.168. It will work. But when they try to connect both, then there may be a problem. So if you see any IP which is already used, try to avoid using that in the VPC. So okay, my company has one AWS account. Over there they are using 192.168 for IP addressing. So in my second account I will not use 192.168. I will use 172 range. So that tomorrow if you have to interconnect both these, it will be possible. There will not be any hiccups. Okay, so which IP address range to use? It is well defined. That is, you can use only the 3 private IPs. So out of those 3, which one to choose? You can choose any one you want, but you should make sure that if already a network exists with that CIDR, try to avoid it. It does not matter another AWS account, because some people what they do, they connect their AWS to on-premises using a VPN connection. So in those cases, you don't want a clash between your private network in AWS and on-premises. So if your on-premises is using say 192.168, then try to avoid using 192.168 in AWS, go to 172 or something like that. Because tomorrow if you try to connect both of them, there may be problems. If you don't connect them, then fine. But when you try to connect, there might be problems. So try to avoid overlaps, because once you create an overlap, it is difficult to modify it and difficult to establish connections. Some cases it is impossible. Some side or the other side you have to change the IP addressing, right? So the CIDR you have to choose carefully, right? So we have to choose the CIDR for the VPC. So what we are creating the VPC. So this number, right? 192.168.0.0/27, 192.168.1.0/26, right? These are called the VPC CIDRs. That is your network's address, right? Your network range. In AWS we call it the VPC CIDR. That is, this VPC can have this range of IPs, right? Instead of representing like this number to this number, we represent it like this. So with this representation, CIDR notation, you can get the complete information about the network. What is the network address? How many hosts are possible? What is the IP address range and all that stuff, right? Okay. So just let me know if you have any doubts.
Um, so let's go to that URL.
Yeah.
Yeah. So here, if I want to specify only mask bit, that's also fine, right?
No,
Automatically it will calculate, right?
no, you have to specify the IP address, right? Which numbers you want to use.
Ah, sir, that's
Yeah.
what. Yeah. IP address and mask bit. That's fine, right? Both.
Yes, any 2 values. One is IP address and any other value you can give. The other things it will calculate automatically, because
Okay.
all of them are interconnected. But 2 values have to be there. With just 1 value, you can't do anything. Usually the IP address, and we give the maximum address for. I mean, if you're just starting off, you can use the maximum address, because you will know, right, how many machines I am going to have, right? That is a easier question to answer. So if you do that, automatically the mask bit will be calculated. Or if you give the mask bit, you can see how many address you can get, right? All these are fixed combinations. It is not, what you say, something that is random. It is fixed, and that is why it is there in the calculator, right? So you cannot have exactly, what you say, 68 IPs. You cannot have. It will either be 62 or 126. There's nothing in between, because of how the octets are placed, right? How it is calculated, right? So you cannot what you say, do something like that, right? Either the mask bit is 23 or 24. There is no 23.5 or something, right? If it is 23, you have 510 IPs. One number higher you go, you have what you say, Let us take, if you take 18, you have 16,000. If you go one number bigger, you have only 8,000. It drops by half. Right? You go to 20, it drops by another half. Right? So you have to choose something that is closest. Right? So if you need 1,000 IPs, choose something like 2,000. 2,000 means what? Slash 21. Right? If you go smaller than 21, that means if you go higher on this number, it falls even lower. Right? So yeah. So these are the only possible values. If it is slash 32, it means that particular IP. You see, it means that particular IP. There is no range. Even though it shows it as a range, for the sake of calculation, it is only 192.168.2.0. So if you want to represent one IP, a single IP, a particular IP, then we represent it as that IP itself slash 32. So we will not use 32 in this calculator. You will be using something between 16 and 28 in AWS. Okay. Even though the possible values are between 1 to 32, in AWS, you cannot create a network bigger than 16. Right? This is only in AWS. In outside networking, you can do whatever the other possibilities. But in AWS, you can create a network only as big as 16 or as small as 128. You cannot create slash 14, slash 15, slash 13. You cannot. In AWS. In outside LAN networking, you can. AWS, it does not allow you to create bigger than 16. 16 means what? 65,536 IPs. That is 36 minus 2, you will see 34 over here. Right? In AWS, you cannot go below this. But practically you can elsewhere. In AWS, they don't allow it at the moment. The maximum size for your VPC will be slash 16. If you want more than 65,534 IPs, you create 2 VPCs, each with so much. But one VPC cannot be bigger than slash 16 in AWS. That is, one private network in AWS cannot be bigger than 16 and it cannot be smaller than 28. Right? It cannot be smaller than 28. But practically, it can go smaller. But in AWS, the allowed is only between slash 16 to slash 28. Okay.
So yeah, so whatever the combination is like 192 or 10 or something, whatever may be, but slash can be 16 between 16 to 28, right?
Yes. Even though according to the rules, you can have slash 8 in the 10 dot range, you can have slash 12 in the 172 range. In AWS, you cannot. It is limited to 16 to 28. This is only in AWS. Okay. In AWS, you cannot create a slash 12 or a slash 8 or a slash 9 or slash 15. You cannot. You cannot go bigger than 16. So it can be 172.0.0.16. So if this number is 12, that means you can have a network. I mean, in 172.16 range, it can be 12 or greater. You cannot go 11. If it goes to 11, then you are including public IPs also. Right? So whatever, this is the private IP address standard anywhere in the world. Right? This is the largest size. That is what they say. This is the largest. But AWS, it does not allow the entire range. It allows only from 16. That is 10.00/16 or 172.0.0.16 or 192.168.16. 192.168.16 means it allows the entire 192.168 range. There is no, what do you say? It does not even allow the entire, because the largest is this. But you cannot create smaller than 28 in AWS. But outside you can create 28, 192.168/16, 17, 18, 19, all the way to 31 you can create. But in AWS, it is limited to 16 to 28 for all the ranges. Right? I don't know for what they have limited it to 16, but I can tell you why they have limited it to /28. 16 is the largest, 28 is the smallest. Right? So now let us take /28. So any network you put /28, the number of IPs remain the same, right? Whether it is 192.168 or 172.16 or anything. If it is /28, sorry, it means there are 14 IPs. 14 plus 2, let us say practically 16 it is, right? 0 to 15. Any number you put here /28 means 16, right? The total count I'm saying. Okay, /28 is what? On paper 16 IPs. 16 hosts you can have. How much is slash 29? The total count will be 0 to 7. That is 8. Right? What is slash 30? You can have 0 to 3. That is 4. Okay? So you see the number keeps dropping. Right? So what happens is in AWS, whenever you create a CIDR, right, for your VPC and you split it up into smaller subnets, right, you cannot use the first 4 IPs and the last IP. First 4 IPs and the last one IP you can't use. So in total 5 IPs are blocked for some special purpose in AWS. Okay. So if you go to slash 29, then what happens? The total itself is only 8. Out of 8, 5 IPs you can't use. Right? So practically only 3 IPs you can use, which is of no use to anybody. If you go to slash 30, the total practical IPs itself is 4, and AWS itself needs 5 IPs. Then it's not possible, which is why you cannot create a network smaller than slash 28. Slash 28 is the smallest network. That is 16 IPs minus 5 IPs. That is, you have 11 usable IPs. This is the smallest network that you can create, private network you can create in AWS. Why they don't allow you to create bigger than 16, I don't know. I mean, they have not given that information, but currently the rule is the biggest is 16, the smallest is 28. Because
Okay. And Siddharth, yeah. So when you was telling like it can be between 16 to 28, right? What I thought was it can be like 60 slash 16 slash 17 slash
yes,
18,
yes,
like slash like that. I correct,
yeah,
right?
yeah, like that only. Between 16 means it can be slash 16 slash 17 slash 18, all the way up to slash 20. You cannot go
Okay.
smaller than this. You can't go slash 15. Smaller the number,
15.
bigger the network.
Okay.
But outside AWS you can. This rule applies only to AWS. In AWS, the private network that you can create should be between 16 to 28, whatever you need. Okay, you cannot go smaller than 28 because you will not have enough IPs, because AWS itself needs 5 IPs for certain things. We will see what are those things, right? So even though we say in this VPC I can have IP between 0 to 31, that is
So
total of 32 IPs, practically you can use only 32 minus 5. That is
so here
22.
yeah. So when you say 32 minus 5, right?
Yeah.
27. So we're taking this an example like 192.168.00 slash 27 is there, right? So here first 5, I mean first 4 and last one, right?
Yes. What is the
So in
first
this
four?
case, 0.1, 0.2, 0. I mean 0.0, 0.1, 0.2, 0.3,
Yes.
correct?
Yes.
And the last one will be something.
Last one is 31.
Okay, okay.
So you cannot use the first 4 IPs and the last one IP in every subnet or VPC subnet, let us say, right? So even though the on paper the total IPs are 32, the first 4 and the last IP is used by AWS for different things to provide you the networking service, because you are not maintaining any DHCP or the router or anything, right? All these are provided automatically by the AWS. Those devices also need an IP. So some IPs are reserved by AWS for some special purposes. That is usually the first 4 and the last IP in every CIDR. So you can have only, even though on paper it is 32 IPs, you can use, that is you can have 27 devices. That is 27 usable IPs. Okay. So you have to be careful when you calculate that. So I said for this subnet we need 25 machines. So if I say slash 27, even though 32 IPs are there, I can have only 27. 27 is enough. I have 25 machines, 2 extra IPs. But if I need to add more than 2 machines into this network, it will not be possible, because practically it can hold only 27 hosts at a particular time, because there are only 27 available unique IPs. Same thing over here. It is 1.0 slash 26. So the IPs are 1.0 to 1.63. So I cannot use 1.0, 1.1, 1.2, 1.3 and 1.63. I can use from 1.4 to 1.62 for my machines, right? So 64 minus 5, so 59 usable IPs. What are the usable IPs from 4 to 62, right? This rule applies in AWS. In real world, it is usually the first and the last IP you can't use, because the first is the broadcast anywhere, first is the network address, last is the broadcast. Same thing in AWS. The first is the network address, last is the broadcast. 1, 2, and 3 are used for different things. 1 is used for the router, 2 is used for DNS, 3 is reserved for future use. It's currently not used for anything for future use. Right? In AWS, the first IP is the router's IP, 2 is the DNS, 3 is for future use, 31 is broadcast. Right? So in any other outside network LAN, the first is again the network address, the last is the broadcast. Those two will not be assigned to any device. Even at your home, if you see 192.168.0.0 will not be there for anything. Right? The router itself will be 0.1. Right? Like you told me, your IP is 192.168.1.100. Right? So I assume at your home it will be something like, if you want to log into the router to configure it, you will go to 1.1. You will not go to 1.0. Right? 1.0 is the network address. It's called the network address. 1.1 belongs to the router. So you cannot use 0, you cannot use 1, and 255 is the broadcast. So you cannot use 0, 1, and 255. Right? So actually the practical number of IPs will be 256 minus 3 in your home network. That is 253 devices you can connect at the same time. Right? Because the IPs start from 2 to 254. Right? So same thing in AWS. 0 is the network address. The first one belongs to the, dot 1 belongs to the router. 2 is for DNS. 3 is for future use. 3 is not used for anything at present. And the last is the broadcast. This is the rule in AWS. Okay. So you have to know this before we actually proceed to start creating the VPC, because it is all about IP addressing and how we, split it up and use it. Right? How we create a group of IP addresses and split them up and use them for our different cases. Okay. And remember, /32 means two things you have to remember. One is /32, I already told you. /32 means you are representing a particular IP address, right? And IP /32 refers to that particular IP. And you will also see something like 000/0. This is a dangerous number. This means anywhere or everywhere. We will use this in the, configuring the rules for the security group and access control list. Right? If you see this number, you have to be careful and you should avoid using this number usually. So what is 000? It represents traffic going to anywhere or coming from anywhere. This is used in the firewall rules. Right? The firewall rules are in AWS, we call it security groups and access control list, where you can allow some inbound traffic or outbound traffic. So in those places, you should try to avoid using this thing. So if you say allow all outbound traffic to 000 means, that means you are allowing all traffic to go anywhere. Right? So in corporate networks, it is not recommended to do that. Right? At your home, okay, all ports are open everywhere, you can access all websites, everything, right? But if you go to your office network and you try to practice AWS, sometimes you will not even be able to connect to your AWS machine, because they will block the SSH port, SSH traffic outbound. Right? At your office, what you need to do, you need to access the internet. You don't need to connect to other services on different ports. Right? So you should remember these two notations. That is /32 represents a particular IP, and 0000/0 means anywhere or everywhere. We will see this value is used in the firewall rules. Anywhere, not only in AWS, anywhere. In AWS, the firewall type of service is called security group and access control list. Over there, in some cases, you might have to use this number. Okay, but this represents traffic to anywhere or from anywhere. Okay. So, okay. So I'll just explain 2 minutes and then we will take a break. Hmm? So now we are going to create a VPC. I told you how many VPCs. You can create as many as you want. VPC is free of cost. It does not cost any money. But it has other components inside it which may cost money. Right? The VPC itself is just you are defining the boundary. You are saying I want a network with 192.168.0.0/24. So this is just a boundary. It is a private IP. It is free of cost. Right? So which location you are going to use, right? I told you which region are you going to use, because the VPC is in a particular region. It is not across two regions. You cannot create a VPC across two regions yet, right? One VPC will be in one region. So you can choose any region. You can choose US East. I will choose maybe for you. Let me see, because I'm using other stuff in other regions. I don't want you to get confused with other networks. So maybe we can use, for you, maybe let us use Canada. Let me see if I have anything in Canada, because I want to start with a fresh region for you. Otherwise, it will be confusing. Because in my other regions, I have other VPCs and other stuff. Let us take some region which I have not used or in which there is no existing configuration. So you can use the US East one because yours is a new AWS account, because it does not matter which region you are using. The steps are the same. Okay. So I will use Canada for you. In Canada, it is fresh. I don't have any changes which I have made. So you can also follow along with Canada, or you can use US. The process is the same, the steps are the same, the numbers will be the same. Just the location I am using is different, because here I don't have any chunk. If I go to other region, there are other VPCs over there, you will get confused. Okay, so I will use the Canada region to show you this VPCs. It is the same in any region that you choose. Which region are you going to choose? Like I said in the beginning of the class, depends on where you want to host your infrastructure. Right? Depends on your project. If you are working for some project in India, say for HDFC Bank, probably you want to use the Mumbai region. So whether you are creating VPC in Mumbai, Canada, Singapore, Australia, it is all the same. Right? So you can use the US East one because it is the cheapest. Because some services might require money, so you can stick to the US East one, that is the North Virginia region for all your practice. Okay, because I'm taking multiple classes, multiple batches, right? So if I put everything in one region, it will be confusing for you people. So I'm taking a fresh region for each class. So I have so many regions, I can choose whatever I want, right? So I will choose Canada for you, and inside Canada, we'll work with the VPC. Okay, and we can choose some CIDR. We will see how to choose the CIDR and all. Okay, so we will take a small break for 15 minutes, right? 9:40. 9:55. I'll catch you guys. Okay.
Okay. Okay. Thank you.
So we just understood what is basic IP addressing, what is a private network, and all that stuff, right? So now let us go to the VPC part. So which region I'm going to use? The Canada region, right? To show you this thing, right? So what is the VPC? It is like a private network. Okay. So in AWS, there are going to be, not only in AWS, even outside AWS, right? You will have other components, right? So one of the first components is called a subnet, right? Subnet. Subnet is a part of your VPC. It is a, like I said, VPC is the CIDR 192.168.0.0/ say you are creating /24. So your subnets are the ones where you are going to put your infrastructure. Like if I ask you where are you living, you will say I'm living in Bangalore, right? So Bangalore, you are living in some area inside some apartment, and you have an apartment number, right? So Bangalore is like the region, right? The area is like the VPC, the apartment is like the subnet, and inside that apartment you have a flat number, right? So same thing, whenever suppose you are creating a virtual machine, right? It will be in some region. What is our region? Canada. It will be inside some VPC. What is our VPC? This VPC. Let us call it the dev VPC. It will be in the dev VPC. Where it will be in the dev VPC? It will be in one of the subnets. Right? What is a subnet? It is just you're splitting your VPC into smaller networks. Right? Suppose, say, instead of IP, I will just use numbers. So this thing, right, 0.0/24 is what? You can have IPs from 0 to 255. Right? So what I am doing is, I am splitting up this like 0 to 100, 101 to 255. You cannot put a machine in the VPC. In the VPC means it is actually inside one or more subnets. It is actually in some subnet. Right? Like I asked where you are living. You are in apartment 101. Where is that? In this subnet, in this VPC, in this region. So even though we say you are living in Bangalore, you are actually in Bangalore, but where are you actually physically present? In 101. So your VPC as such is just the boundary. Your VPC is the area. It is like your area. You are defining your area. I am somewhere in this area. Right? So VPC is just the range of IPs that you can use in your private network that you are going to split up into one or more. You can have two subnets, or the entire 0 to 255, you can put it as one subnet. Right? So why you will have multiple subnets, or why you need to have multiple subnets? Why can't you put your entire VPC as one big subnet? You can put if you want to, but again, like I said, similar things should be in the same groups. Like you said, okay, the dev VPC, what do they have? They have all the dev infrastructure. What is there in dev infrastructure? Let us say you have some app servers, some web servers, some DB servers, right? So each of this is a layer or a stack or something like that, right? Each of this is similar. So you probably want to put all your app servers in one subnet. You want to put all the web servers in another subnet. You want to put your DB servers in a subnet, because the rules for each of them will be different. Different people are accessing different services. Different services will expose different ports and IPs, right? So you want to club similar stuff inside the dev infrastructure in one or more subnets. That is, you don't want to mix up. You don't want to put your app, web, and DB all in the same subnet. It will work, but it is not good architecture. Okay, so whenever you're creating an app server or something, it will be in some subnet. Which subnet? Probably your app subnet. That is some subnet 1, 2, 3, we will call it. So what is a subnet? It is just you're splitting up your VPC's available IPs into smaller networks, right? Okay, so why you need to have multiple subnets in real time? So like this, there will be multiple layers in your architecture. So the similar stuff will share similar subnets. So there might be two subnets for app servers, right? You can have two subnets for app servers also. We will see all that, right? But subnet is basically splitting your VPC. You can split up into one big subnet or multiple smaller. That is, your total IPs are 0 to 255. That you split 0 to 100, 101 to 255, or 0 to 255, or you do 0 to 50, 51 to 100. Like that, however small bits you want, you can split it up depending upon how many machines are going to sit in each subnet, right? So for all this, the main thing is the diagram, because in the AWS console, you will not see the diagram, right? In the AWS console, you will not see the diagram. You will only see VPC, you will see subnets and all the stuff. So you cannot visualize it easily. So for practical purposes, or even in real time, right? Anywhere you go, prior to you creating the network, you should have the network diagram, right? How you want to lay out your network. So if you're building a house, people are not going to come and start building immediately, right? Even though they know how to build house, right? The workers know how to build the house, but they build it according to the plan given by somebody, so that they know first they have to do this, then they have to put this, they have to do this, right? So without that also, you can build a house without a plan. Simply start building, put whatever you want, wherever you want. But tomorrow if somebody has to, what do you say, they need a diagram or something, they may not know, right? So anywhere you go, you need the network diagram or the architecture diagram. Either you draw the diagram or somebody draws the diagram and gives it to you, you implement it. It depends. In some companies, you might have to do the architect and build, or you might just have to architect. In some places, somebody will architect and give you, you have to implement it, right? But always, prior to creating this VPC or anything in AWS, you need to have the architecture. What is going to sit where? Okay. So for example, let me show you a diagram, right? So the VPC has other components also, right? What I told you is just a basic, just what is VPC, what is subnet. So it will look something like this. This is just a so there are different architectures, right? So if you are building a house, right, there are different ways in which you can lay out the rooms and all the stuff, right? Right. But basically, most of the houses will be similar, right? They will have a kitchen, they will have a bedroom, they will have a bathroom, they will have a hall, right? They may have more bedrooms, less bedrooms, more toilets, less toilets, bigger kitchen, smaller kitchen, right? But those components more or less will be there in all the houses. But do they have to be there? No, right? But will they be there? Yes. Mostly in most of the houses, you will have a hall, a bedroom, and a kitchen and a bathroom, right? So the VPC is also like that. So it is not compulsory to have all the components, but most of them will be there for practical purposes. The only two things that have to be there in the VPC, VPC is only VPC. With only VPC, you can't do anything because VPC is just the boundary. If you want to look at the diagrammatic representation for this, right? Let me try to make it bigger, right? This is just an example, right? So we are in some AWS account, right? We have chosen some region, right? Canada. So when you create a VPC, which is the green line, right? The green boundary, you're just defining that I want to use this CIDR, something like this. So you get that range. Other people also can use the range because VPCs are isolated, right? So you are saying I want a VPC with 10.0.0.24. That means you get 256 IPs. That is, you're just defining the boundary in that region. Okay. So now when you create a machine, you need other stuff for the machines to work. So after you create your VPC, you will don't worry about public or private. So you have a green subnet and a blue subnet, right? So the subnet is where your actual machines, your databases, your other infrastructure sit. Where is the subnet? It is inside the VPC. Subnet is like your apartment thing. VPC is your area, right? So the VPC is just the boundary. You split up this VPC CIDR into smaller parts. That is, if this is /24, your subnet can be, this number can be bigger. That is 25 or something, right? You can split it up into smaller. This means you have 255 IPs. So maybe you can have one subnet with 100, another subnet with 100 or 50, 50, right? Like that, depending upon how many devices you want to put in that, right? So your VPC is split up into one or more subnets. Where are the subnets located? They are in the availability zone, right? We know what is a region and what is a availability zone, right? So let me take this diagram. So when you go inside AWS and you say create a new VPC, what is happening is you get something like this, right? Suppose you choose Canada. I think it has 3 availability zones, right? So let us check that. If you go to Canada, you have US East, you have 6. Canada, we have 3. Yeah, we have 1A, 1B, 1D. What happened to 1C? I don't know. They have 3, right? Canada, they have, I think they should have 4. Wait 1 second. Let me go and don't worry about what I'm doing. So I'll show you again. Canada has 3 availability zones called A, B, and D. I don't know why C is not there. They have named it A, B, and D. Okay. So Canada has 3 availability zones. Okay. Or Mumbai has 3 A, B, C. US East has 6 A, B, C, D, E, F. Okay. So we are using Canada. It has 3. So when you say create a VPC, what is created is something like this. Because in the console you can't see the diagram. This is what is actually there. That is in Canada, right? The region which we are choosing, right, is Canada. So in Canada, you have 3 availability zones, A, B, and C. So when you say create VPC, where is it being created? It is created across all the availability zones. Canada has 3. So the VPC is spanning across all availability zones. Okay. You are creating a private network that spans across all the 3 availability zones inside Canada, or all the 6 availability zones across US East one. You cannot create a VPC that is only in availability zone A and B. When you create a VPC, by default, the only thing, you define the network which can span across all the availability zones in that region, right? So now I cannot launch an instance here. So if I have to launch an instance, I have to create a subnet. So the subnet which you create, it will be in a availability zone. The subnet which we are creating, that is inside the availability zone. That is not across availability zones. So you can have subnet 1, you can have subnet 2, you can have subnet 3, you can have subnet 4, you can have subnet 5, subnet 6. You cannot have like this, right? Each subnet that you create will be only in one availability zone. If it is subnet 1, it is there only in availability zone A. If it is subnet 3, it is there only in availability zone C. If it is subnet 6, it cannot be across two availability zones. Okay, the VPC is across all availability zones, but the subnets which you create will be in a single availability zone. They don't span across availability zones. This is a very important question, because you should know that one subnet is equal to one availability zone. It is not the other way around. Other way around means, in one available, people think in one availability zone we can have only one subnet. No, in one availability zone you can have as many subnets as you want, right? But if you take a single subnet, whether it is subnet 1 or subnet 5 or subnet 7 or subnet 2, it will be only in any one of the availability zones. Got it? So when you create a virtual machine, right, or a database server or something, where are you putting it? You are putting it in some subnet, right? So that machine will be only in that subnet. A copy of it will not be in a different subnet. So you are creating a virtual machine in a single availability zone. So when you create a server, it is there in this subnet. Indirectly, what it means, it is there in availability zone A. It is in 1A. Even though we say the machine is in 1A, in 1A it is in some subnet. I am saying he lives in XYZ apartment. So actually in XYZ apartment, some flat number you live. But while speaking, we say this app server is in availability zone A. So technically it is in availability zone A inside some subnet. It will not be in two subnets or across availability zones. No, that we have to make use of. If you want high availability, then you create, say, like I said, you will have subnets for different layers, right? For your app server, for your DB server. Let us take, we have two layers, app and DB. Let me clear this up, right? Now let us say you want high availability. Your architecture is something like, you have an application server and behind it you have a backend DB server. So what you can do, I can say in availability zone A, I can create one subnet, right? I can put my app server here. I can create another subnet. I can create a DB server here, right? So your application will work, right? Now what happens if this app server has a problem? Then your application will be down, right? Your service or application or whatever you call it, it will be down. Either the app server goes down or the DB server goes down, your application will be down. Okay, the app server and DB server are working fine. Okay, and you want to protect yourself from, if app or DB goes down, I want to be protected. So what you will do, let me draw this diagram more clearer. Let me create one subnet here we have, one subnet here we have. So here you are putting the app server, here you are putting the DB server. So now if either the app server or the DB server goes down, your application is down. So to avoid that, you are putting another app server and another DB server. You are doing some replication, right? And here you are doing some clustering or something, let us say. So now even if one app server goes down or one DB server goes down, your application is still up. You are getting some amount of high availability, right? So either one app server or one DB server or one of each go down, still your application will work using the other app server and the backup DB server or the slave DB server. Okay. But now what if availability zone A has a problem? This in AWS side, some problem is happening. In the availability zone A, what is availability zone A? It is an isolated location inside that region. Like I said, in Bangalore, one availability zone might be in in Electronic City, and one may be near airport. So you are using only one availability zone. You are using only the airport availability zone. So if something happens there, like a internet disruption, power cut or something, then what happens? Even though your servers are technically working, because of the power outage or the network disturbance at A, these might not be reachable. So what happens? Even though you have two app servers, 2 DB servers, if the problem happens at availability zone A, then your service will be down. So how can you avoid that? We need two app servers, right? We need 2 DB servers. So what I did in the first example, I put everything in availability zone A. Then the single point of failure is availability zone A. So how can you avoid this? So maybe you can put one app and 1 DB in availability zone A, one app and 1 DB in availability zone B. So the same thing, you are keeping the same number of machines. You are not increasing the number of machines, right? You are keeping the same 4 machines, but instead of putting everything in one availability zone, you are creating 4 subnets. One here, one here, one here, one here, right? Both these are app subnets. That is, they will hold your app servers. Both these are DB subnets. They hold the DB server. So you put one machine here, one machine here, one machine, and you configure their connectivity. So now what happens? Even if one app server goes down, no problem. Even if 1 DB server goes down, no problem. Even if entire availability zone goes down, only these two will be affected. These two will not be usually affected, right? So using the same 4 servers, the cost is the same. Whether you use one availability zone to put all the 4 machines, or you use 2 availability zones to put 2 machines in each, the cost is the same. But you are improving your availability, right? So that we have to do. Okay, that we have to do. That's what we are learning in the architecture, right? How to place your devices, where to place, how to use multiple, how do you use multiple availability zones like this. So when you create your VPC, it is automatically across all the availability zones, but you have to make sure that you are placing your devices correctly, your infrastructure correctly. Don't put everything in a single availability zone. The architecture's first rule is use multiple availability zones. So then you can say, what if all the availability zones fail? Then bad luck. Then you have to use the other region. If for you so much availability is important, then you have to create a copy of your infrastructure in another location. So Canada can be your primary, secondary can be US, right? If you have a very important application that is used by people across the world, right, and you want it to be protected not only by failure against availability zone, if something happens in Canada, then maybe you want to have a backup in the US that you have to create. US is also provided by AWS, right? So you create another VPC there, you replicate your infrastructure, and you assign Canada as your primary and US as the secondary. For you, it is primary and secondary, but for AWS, I told you all the data centers, all the regions, all the availability zones are always hot. They are always available, right? You can assign whatever you want as the primary and secondary. This is for people who want to be protected against any problems that might affect the entire region. But mostly 90% of the people use a single region with multiple availability zones for each project. Like I said, if you're working for for some company in Canada, right, they probably want to host their infrastructure inside Canada. But inside Canada, which availability zone to use? We should use at least 2. Right? Don't put everything in one place, in one VPC. In one VPC is fine, but use different subnets in different availabilities. Okay. So the important thing is here is one subnet is equal to one availability zone. So whenever you create a subnet, it is there only in one availability zone. It does not span across 2 availability zones. Okay, same thing for the VPC. The VPC is there in that region. The VPC cannot span across 2 regions. You cannot create a VPC where it spans across both Canada and US. You cannot have one VPC that spans across both Canada and US. You cannot. At least at present, you cannot. What you can do is you can have 2 VPCs, one in Canada, one in US, and you can connect both of them. Okay, but you cannot have one VPC across 2 regions. That is currently not possible. Okay, but you can have two VPCs in different regions and you can connect them. Okay, we will see how to do that also. Okay, so I hope you understood the concept of VPC and the subnets. Right, subnet is just a portion of your VPC which you assign for a specific layer in your what do you say, architecture or right your environment. Right, so you want to put the similar stuff in this what do you say, similar subnets, because for the app what do you say, for the app machines you might open the port 80 and 443, but for DB you are not going to open 80 443, right? DB will not be exposed to the outside world, right? The DB needs to connect to the app. From outside people will not access, don't have to access your DB, right? So for to provide that security and all that stuff, right, you need to segregate similar stuff into similar subnets, right? So you have multiple environments like dev, test, and prod. So what is a good practice? For each, create their own VPC, right? And inside the VPC, inside the dev, you have different components, right? You have app server, DB server, right? The middleware, right? Backend or whatever, big data, whatever you have, right? For each of them, have a different group of subnets, one subnet in each availability. For app server, have one subnet in A, one subnet in B, because all these are free. VPC, there is no cost. Subnet, there is no cost. The cost is only for the machines that you launch. Okay, so how can you make your architecture highly available? By doing something like this. We have to do. AWS has provided the regions, VPC, subnets, availability zones. How we maximize it, that is up to us. Okay, so the rule is pick a region.
Siddharth, there will be a one. So there will be.
Yeah, go ahead.
Hello. Yeah, so there will be a one VPC for per region, right?
No, you can have many VPCs. That's what I'm saying. Suppose you're saying Canada, you have a project X, right? You are choosing Canada. So project X will have 3 environments. Let us say dev, test, and prod. So you can put all 3 in the same region, right? Inside Canada,
Multiple VPCs in a region.
Yes,
so
you
multiple
can,
VPCs in a region. Huh?
Yes, you can have, but each VPC is isolated from each other. Like I said, in your office, they will have multiple VLANs, right? They will have one VLAN for the development team, maybe one VLAN for the accounts team, maybe one VLAN for the management team, maybe one VLAN for the production. In case, assuming you're doing everything on premises, they might have something like this. That is, everything is there in one local network, but it is split up into virtual LAN so that each is isolated from the other. If you want, you can interconnect them. Right, anywhere the concept is the same. You can have another private network inside your office also. Right, so inside a region, you can have as many VPCs as you want. It does not have to be across different regions, but one VPC will span across all the availability zones. So like that, in Canada, you can have up to, by default, you can have up to 5 VPCs. That is the default limit. If you want more than 5 VPCs, what you do? You request for a limit increase. It is not a hard limit. By default, you can have 5 VPC per region. Okay, you can have 5 VPC. Suppose you are doing multiple projects, then for each project, right, you will need 3, means you will need more. Right, 3 might not be enough. Okay, so they provide. I mean, you can create up to 5 VPCs per region by. I mean, it's the current limit. If you want, you can request for a limit increase. So now, say you are doing 2 projects, you need 6 VPCs. Then you say, I need another VPC. I have more projects, more environments. I can create, right? So there are different ways of doing it. You can have what do you say, one VPC per environment, or you can put everything in one VPC and you can divide it into different subnets if it is a small project, right? But I'm telling, most of them have a different VPC for different environments. I can put all 3, dev, test, and prod in one VPC. VPC for project X, right? And I can just manage by different subnets, right? I will create a subnet for dev. I will create a subnet for test. I will create a subnet for prod. If it is a small project, right? Or maybe, like I said, in some cases, some companies, they keep the dev on premises, right? Dev and test may be on premises. Only the prod might be on AWS, right? There are different possibilities. So in those cases, you don't need the dev and test VPC on AWS. Only the production environment is on AWS. The dev is on premises, right? So here we are assuming that you are putting everything in AWS. Your dev, test, and prod in AWS means ideally 99% of them will have a different VPC for each, but it is not compulsory. That is the best practice. If you already have some infrastructure on premises, you want to keep the development environment on premises, you can keep it. You manage that on premises. You move only the production to AWS. You have a VPC for production, right? So that is up to you. What your architecture is, how you want to do, right? So you can have as many VPCs as you want in a single region, but each of it is isolated from the other. Like I said, you can have two VPCs with the same CIDR, it will work, but you cannot interconnect them, right? So which is why always it is better to, what do you say, when you are creating multiple VPCs also, right, it is better to use different CIDR so that there is no overlap. Okay, because if there is an overlap, it will become a problem. Okay. Okay. So the region Canada can have multiple VPCs, right? You can have multiple VPCs. That's what I said. Now we are just talking about one VPC. All the VPCs, the process is the same, right? So we are creating a VPC for dev. Then we will create a VPC for test. Both are in Canada only. If you don't want, you want the production in US, you do that. You keep the dev and test in Canada. You keep the production in US, right? However you want to do, right? Or however they ask you to do it, depending upon, suppose your client is from the US, the production has to be in the US, but they are okay having, because the development team is in India, so they want to put the development machines in the India locations, fine. The dev VPC will be in India, the prod VPC will be in US, right? But you need a VPC for each environment as a best practice, right? So you can put it wherever you want, but the thing is, one VPC will be in one region only. This VPC, the VPC which you create in Canada will be in Canada only. It will not spread across to the US. The US it's a different VPC. Okay, and you can interconnect them using a peering connection, right? So a VPC is in a specific region and a subnet is in a specific availability zone. Okay, the subnet cannot be spread across two availability zones. One subnet will be in one availability zone. One availability zone can have multiple subnets. Okay. Okay. So the first component is the subnet in your VPC. Because without subnet you cannot put anything. Right? Without subnet there is no use for a VPC. VPC is just the boundary. You are saying it's like you are buying a plot. From here to here it's my plot. That's what you are marking with a VPC. You are just saying this space is my space. This with this IP range from 1 to 255, 192.168.0.0 to 0.255 is my network. Is my private network in Canada. Another person can also use the same private network. It does not matter, right? But because each of them are isolated from each other, right? Each is its own boundary. It is private. AWS has created. I mean, we create it like that. Okay. Yeah. So that is that photo diagram, I think. Yeah. Okay. So your VPC is just the boundary, the green box. Inside the VPC, you have multiple subnets. These are just some of the components that will be inside most of the VPCs. Right? Do everything have to be there? No. Okay, will everything, will whatever you see here be there? Mostly 99% of the VPCs, these components will be there, right? So first is you create the VPC by choosing the region. Then inside that you create a one or more subnets. Like here I have the green subnet and the blue subnet. Both of them are in the same availability zone. Okay. So the first component is the subnet, which is a part of your VPC. Right? You can have subnets, one or more, right, inside your VPC. The VPC itself is just the boundary. Then what are the other components? Then you have something called security group and access control list. The network access control list. These are like the virtual firewalls provided by AWS. Right? This is like the virtual firewall provided by AWS, where you can control what traffic can go out or what traffic can come in. Right? You can control the inbound and outbound traffic for your machines. So they can have their own internal Windows firewall or Linux IP tables. All that is inside the OS. This is provided by AWS outside. Right? So think of security group like your apartment door and the access control list like your watchman. Right? So where are you? You are living in some apartment, right? Building, and you are living in some flat. Right? So if you have to reach the outside world, if you have to go out, first you have to cross your door. Right? Then you have to cross your watchman, the gate. Same thing, if somebody is coming inside, if they have to reach your house, first they have to cross the watchman, then you have to allow them through your door. Right? So AWS provides two layers of protection. Suppose you create a virtual machine here, it will have a security group, and there will also be an access control list. Okay, there will also be a access control list. So the access control list is like, you can say, the first level of protection or the second level of protection, depending on which side you are looking. So if traffic is coming from the outside world into your VPC, first it has to cross the access control list. Only if the access control list allows, it will come till your security group. Only if your security group allows, it will come to your machine. Same thing for the outbound. If you want to send traffic out from your machine, right, it has to go out through the security group, then it has to cross the access control list and go out. Right? So this security group and access control list are like the virtual firewalls that AWS provides, so that you can, what do you say, lock down, or you can secure your the VPC and the stuff inside it. That is all in our control. Right? What ports to open, what IPs to allow, all that you can control whatever you want. They have provided a mechanism for that. Right? All this is at the AWS side. If you want inside the OS, you can have your own Windows firewall or other stuff. All that is optional. That is secondary. These compulsory we need to use. Right? And then you will have something called the route table. Right? Right? What is this route table? It is a table which contains some entries. Right? Basically, it will specify how the traffic has to flow. Right? Suppose you go to a new place. Right? You go to a new city. So how do you know? Suppose you want to go from the railway station to your hotel. How do you go? You open the Google Maps and it will show you the path to take. Right? Go like this, take left, take right, and all that stuff. Right? So in networking, you have a route table. So what does the route table specify? It specifies how the traffic has to flow inside or outside your VPC, or inside to outside your network. Which path it has to take to reach the outside world. That is what is routing. What is routing? You are defining a path for your traffic to flow. Traffic to flow where? Within your network, outside your network, for traffic coming from outside, right? All that you need to specify. We assume that it works, but it works because there is a routing table or a route that is already created for us, right? But in AWS, right, when you are creating the network, what do you say, anywhere, not only in AWS for that matter, even outside, you need to specify the routes and all that stuff. Otherwise, the machines, they will not be able to talk to each other, right? Or they will not be able to go out to the internet. So you need to say, if the traffic is going outside to the internet, how it should go. If it is internal traffic, how it should flow, right? So that's what will be there in the route table. Okay, these are just some of the components which will be there almost in every VPC. Some of them are compulsory, some of them are optional. and then there is something called the router, right? So don't look for the router, you will not see any router. If you come to VPC, you will not see any router. Okay, it is there. When you create a VPC, the router is there, but you cannot see it. It depends. The router means indirectly we are referring to the route table, right? You cannot see a router as such like how you would in a real environment, a Cisco router or something. Here you don't have to worry about configuring any brand specific devices. The router is there. What we do is we just add the routes. You cannot see the router, okay, but it is there. In every architecture you take, right, you will see the router there. In the diagram it will be, but in the AWS console you cannot see it, right? So any, what do you say, the network diagram that you draw in AWS or the architecture diagram, it is a good practice to include this router. Even though, I mean, it will be there, everybody knows it is there. It is called the implicit router. Explicitly you cannot see it, but it is there. What is this router doing? It is following the rules given in the route table. If traffic is going here, it has to go like this. Traffic is going somewhere, it has to go like this. That is what it is doing, right? There is a router in every VPC, which is why said the second IP, right? Suppose, like I said, the first four, right? First four IPs and the last one IP. So in the first four IPs, suppose it is 0.0, second IP is 0.1, 0.1 is assigned to the router, which is why you cannot use that IP. There is a router provided by AWS in your VPC, right? When we say the router, we are actually referring to the routing table, because the router as such, you don't do anything. You cannot even see it, but it is there. It's called the implicit router. Okay, it is present. And then you may have something called the internet gateway, IGW, right? IGW is a device which lets you connect to the outside world, right? Like I said, at home, if you need to connect to the internet, what you need? You need an ISP. You need a way to connect to the ISP. Here in AWS, it is provided via a internet gateway, right? You need to create an internet gateway, right? So if you don't have an internet gateway, what happens? These machines can talk to each other, right? You buy a Wi-Fi router, right, at home, you connect your machines, well and good. You can talk to your machines, between the machines. Your LAN will work fine, but these machines cannot reach the outside world. If they need to reach the outside world, you need a connection to the outside world, which is provided in AWS via something called the internet gateway. Again, here you don't need to configure any, what do you say, like ISP style configuration. You just need to create and attach this. Your work is simplified. You should know what the device does, because you don't do much of, what you say, like core networking configuration, right? We should know what each device does and where to place the device, right? Where to place the device. Suppose you get an internet connection, right? From your ISP, they give a cable. So where do you plug in the cable? On the router, there will be a separate port for WAN, right? It will be usually in a different color, right? You will have 3+1 or 4+1 ports, right? 4 ports will be in one color, 1 port will be in yellow color or something. That is the WAN port. If you take the WAN cable and connect it in the LAN port, your internet might not work. So you should know where to put what device, where to connect it. Because if you connect it wrong, then it will not work. If you take your laptop's cable and connect it to the WAN port, it will not work. It will connect, physically it will connect, but it will not work, right? So in AWS, you don't have any physical connections. You have to know where to place the devices, how to place them, right? Which is also mostly simplified for you, but you have to know where the device is actually located, because for troubleshooting it is important. Because people will say, I am not able to connect to this machine, or from this machine I am not able to access the other machine. I am not able to connect to the DB. My website is not working, right? So all those things, how you troubleshoot, you can troubleshoot only if you know what component is where. Simply blindly you cannot come and, what do you say, simply reboot your server. So laptop is not working, reboot. Like that you can't do in real time, right? So you should know where to check the problem, right? So you should know what are the components. Suppose you have a car or a bike, right? It's not starting. What you will do? First thing is you will check whether there is petrol. If you know a little more mechanical, you will go check the other stuff. Otherwise, you will take it to the mechanic. He knows what to check. Bike is not starting. Check if petrol is there or spark plug is working or whatever he will check. Right? So same thing here. You should know which component is sitting where and how they interact with each other in the VPC. Because almost every service needs a VPC to run. Okay, so these are some of the components in the VPC. Okay, and there are other components also. I will just show it to you. I think I. So all this is available in the AWS documentation. What document I want you to download or refer to is called the VPC user guide. VPC user guide. So remember, VPC is a vast, what do you say, subject. There is a specialized exam for the networking itself, but you don't need to go so deep. Okay. So what you can go through today is, right, this VPC user guide. Just put VPC user guide in Google. The first link you get is that. Okay. So whatever we are going to learn, everything is there in this thing. Whatever I'm going to show with diagrams, it will be here. I have taken it from here only. Everybody takes it from here only. Right. So what is the VPC? That is what we saw today. Right. What are some of its components? Some components you don't have to know. Some components we will be seeing. Right. Today we spoke about VPC, subnet, route table, internet gateway. VPC endpoint we didn't see. Ignore it. We will see it later. Right. How many VPCs you can create? I told you, right? I told you can, by default, I think 5 VPCs you can create. If you want, you can request for a limit increase. If it does not, if it is not sufficient, if the current quota is not sufficient, you can always request for more. What is the pricing? I told you, a lot of stuff are free, right? The VPC itself is free. The subnet is free. Security groups are free. But the machines which you create inside the VPC, obviously you have to pay for them. But other components like site-to-site VPN, NAT gateway, right? For these things you might have to pay. These are also components of the VPC, right? I showed you some of the components which will be there in most VPCs. But apart from this, there are other components also. Those might cost money. So we should not say the VPC itself is free. Most of them are free, but certain components that you use inside the VPC will cost you money, right? You can just look at this, and then you can just look at the IP addressing part, which is what I explained. Same thing will be here. What is a private IP address? What do you say? What are the ranges? Right? All that will be specified over here. Right? IP addressing behavior. Right? Some of this stuff. Right? You can go to working with IP addresses. Right? So anyway, we are going to see how to do all these things. Right? Yeah. You can just look at what is VPC and subnet. This is what we saw, right? Today, VPC and subnet basics. What is VPC, right? So the same diagram only they have also taken, right? So they have given the different, because in the console you can't see these diagrams. So that is why first you have to draw the diagram and then implement it. So you can just go through the first couple of pages. What is VPC? How VPC works? A little bit, right? So we will be seeing everything, right? Most of the components, right? So here is the basic VPC, which basic components which will be there in pretty much every VPC, right? And there are other components such as these, right? There are other components such as this, right? You have your VPC. They are made up of what you say, internet gateway, subnets. Don't worry, public and private, will come back to that. You have subnets, right? You have the routing tables, access control list, security groups, right? And then you have something called a NAT gateway. These will probably be there in every VPC. These things, right? VPN gateway, customer gateway, VPC endpoints may be there in some networks. And VPC peering also mostly you will see in most real-time environments. We will be seeing VPC peering. These things, right? The VPG, right? The VPN gateway, right? The customer gateway. These are used for connections between AWS and your on-premises. This actually comes in advanced networking. This is to establish a connection between your AWS and on-premises networks, or as we call site-to-site VPNs. That is always on VPNs. That is, these two are always connected. From home, how you connect to your office? You connect to a VPN using a VPN client or something. right? But if you want to connect two locations, they should always be connected ideally, right? Suppose your office has two locations in two parts of the city. If it's a big company, probably they have connected both the locations using a leased line or something, or maybe over the internet they have created a site-to-site connection, so that people in this site, they can access the services in the other site as if they are local over the local IPs. So for people who want to connect their AWS infrastructure with on-premises or AWS with Azure, right, or AWS with the Google Cloud, so they will also provide what you say, some service at the other side. If it is on-premises, on-premise you should have a router or something like that, right? You should have a device on-premises which can do site-to-site VPN, like a Cisco, what do you say, ASA or something, right? Which supports site-to-site VPN, because that VPN is always connected. So at AWS side, they will give you a gateway device like the Cisco router. They will give you a managed service. At your side, you need to have the customer gateway, right? So similarly, Azure will provide something like that at their end. So you can connect your AWS with Azure or with anything basically. All these providers have something or the other. All this comes in advanced networking. We will not go into that, but we will just see at a high level what are the possibilities, right? In order for you to do the gateways and the site-to-site VPN, you should have more knowledge about what you say, the routing and switching, CCNA or something like that. Because we are not core networking, right? You should know at least the other components which are commonly used. If you have to configure a gateway, then either you take help from somebody or you follow the documentation and you do it. Okay, mostly you may not have to do unless you are a core networking specialist, but yeah, you should know that what is there. If somebody asks you, can I connect my AWS to on premises, right? I want to connect AWS to on premises using site to site VPN, then which service to use? You need to use the VPN gateway and the customer gateway, right? The VPN gateway is at the AWS side, the customer gateway is what is at the customer side, that is the device at the customer side. It can be a Cisco router, a Juniper router, whatever it is, or it can be another cloud service. They will also provide some customer gateway, or the other way around. If somebody wants to connect from what do you say, from Azure to your AWS, you have to give them the customer gateway, or you have to create a customer gateway. Yeah. So either ways, either can be the source. All that comes in advanced networking. A few people use that as well, but almost every VPC will have internet gateway, public, private, subnet, NAT gateway, routing table, access control list, and VPC pairing. This compulsory will be. These are the core components. There are other stuff also, right? There are other components also. Maybe some of the components we will see, some is not required for us, right? Like how you have this endpoint services, managed prefix list, DHCP option list, right? A lot of these are is beyond the scope, right? Transit gateways, all these are what do you say, advanced networking stuff, specialty stuff, network specialty stuff. Okay, so these are some of the core components that we will be talking about.
Siddharth, like I mean, if you want to connect to site VPN, so is that the only option we have, or any other ways to connect from AWS to on-premises?
See, when we are learning for the AWS exam or AWS part, we have to look at what are the service AWS is providing. For everything, there is going to be an alternate. For pretty much anything today in IT, right? There will be a different way to connect. But AWS, they don't expect you to know that. They expect you to know what services you can use from AWS to connect. You understand? So if you want to use a site-to-site VPN in AWS, the way that, I mean, the products that AWS provides, that is their own product, is these things, right? The virtual private gateway and the customer gateway. So do you have to use only these two to establish a VPN connection? No, because you have other products and services provided by other vendors also. Like if you just search for VPN over here, right? You have different providers for VPN, OpenVPN, Netgate, Cisco, pfSense, right? All these are some type of a VPN service which will let you what do you say, to connect multi-tenant environments. But to use this, you have to know how to use this. Like I said, Cisco ASA you should know how to use, right? This is what I said, Cisco ASA at your end. Or you can use it now, it is available as a virtual appliance. So, but you should know how to use this. This is what you say, specific to the vendor. You can create a VPN using other stuff also. Fortinet, if you are comfortable with that, you can use it. Foxpass, IP VPN. So there are a lot of hundreds of services with which you can establish a VPN connection, but they will not ask you about that. I mean, your company might ask you, they might be using something, but you should know that product, right? Cisco ASA and all that. But what is out of the box solution native to AWS is customer gateway and VPN gateway. So you don't need to install any software or something. You just have to know what is site-to-site VPN, what is an ASN, right? What is BGP protocol, right? Border gateway protocol. All that is general networking stuff for routing and switching. You don't need to physically configure any branded device, right? If you want to go for that, that also you can do. But for that, you should have that specific knowledge on that device or that product. Okay. Okay. So here are some of the things that we just saw, right? The VPCs are specific to the region. Very important. They don't span regions. You can create up to 5 VPC per region. If you want more, you request for a limit increase. Then we will talk about the default VPC in the next class, right? And then you can have up to 200 subnets per VPC, right? So you can split up your VPC into 200 smaller networks, but nobody really uses 200, right? But that is the maximum limit that you can split one VPC into, right? VPC is what? Is that number 1 to 255. You can split that up into 200. That is one IP each, or if you have say 65,000 IPs, right? 200 are the possible number of subnets, but nobody uses 200. But yeah, that is the maximum possible per VPC, right? And then you can use IPv4 or IPv6. We are not going to IPv6, right? We are going to worry only about our IPv4, which is what 99% of the people are using. Now slowly some companies are adopting IPv6. Again, if you have to know IPv6, you should, what you say, you should know IPv6. Again, that is a totally different, what do you say, class on networking. Okay. And like I said, a lot of them, some of the core components, they don't cost anything, like the VPC route table, the security groups, access control list, internet gateway, subnets, VPC pairing, all those are free because they are just some logical definition. They are just logical. You are saying, I want this VPC, this CIDR, this subnet. So they are free, but some things will cost money, like the NAT gateway, VPN gateway, customer gateway, all those cost money. So you have to be careful. We will see those things, right? So these are some of the key features or some of the basic stuff in the VPC. Okay, and then always remember these two notations I told you. /32 means a specific IP. It is represented as /32, and 000/0, which represents all IPs or to anywhere or from anywhere. This is what 00 represents. Okay, you will see this in the rules that we create. 00 will be in the rules. It is not assigned to any device. It will be in the rules for the security group or the access control list. It is like giving access to anywhere on the internet, right? Okay, so these are some of the core components. So they have another option also in AWS, right? So if for you the site-to-site VPN is not enough, right? This also comes in advanced networking, but I'm just telling you, you can just note it down if you want, because this might come in the exam. I cannot show you this. They have a service called direct connect, right? What is this direct connect is? If for you VPN is not enough, so how is the VPN traffic going? It is going over the internet, right? The VPN traffic, even though you're establishing a connection, how is it actually traveling? It is over the internet. It is a tunnel that is created between your office and your AWS, or your office and your home when you connect to it. You don't have a physical line, right? When you go home and you connect to your office VPN, you connect over the internet. You don't have a dedicated line from your home to your office, right? You are creating a tunnel, a secure tunnel between your office and your home when you connect to the VPN, or when you use a site-to-site VPN. Site-to-site VPN is that it means the tunnel is always there. You don't log in and log out. It is always connected. So for people whom it is not enough, in some cases, because over the VPN the speed might be slower, right? Especially if you are transferring large amounts of data. So for that, AWS has provided an option called AWS Direct Connect. So it is like a physical connection that is established between your on-premise and AWS through some intermediary. That is usually your ISP. Like for in India, Airtel, Sifi, all these are AWS Direct Connect locations. So what happens is this Direct Connect location is like your ISP. It's managed by your ISP, right? This on-premise is your office, right? And this is AWS, some region. So you can create a connection between this and this using a direct connect location. So what happens is, right? So your ISP, you have to contact your ISP. You cannot do it straight away, right? So they will lay a connection between your premises to their network, and they are connected to the AWS end, right? Your partner, right? So this direct connection location is your ISP or your partner cage or whatever they call it, right? It is your ISP like Airtel or Sifi or whatever. They will have a router which is connected to your office router, right? So they establish this connection. So it is like a physical connection which provides a more consistent bandwidth than at a lower cost for people who transfer large amounts of data between on-premises and the cloud. Right? It is going to be more consistent than establishing a site-to-site VPN. Right? Again, it is not for small, medium stuff. It will not be cost effective. If you need a lot of bandwidth, you are somebody who transfers a lot of data between on-premises and the AWS cloud to and fro, right? Then for you probably the direct connect will make sense, either cost-wise or even performance-wise. But if you are not transferring much data, then it does not make sense, right? So you cannot do this. You cannot open the console and do this. You have to contact your ISP, right? They will help you configure this direct connect. This is like a physical connection between you and AWS through your ISP, right? They are called direct connect partners or something, right? So maybe you can just open it, right? So it depends on where you're located and all that stuff, right? Right? So the process is this, right? You create a request, you download the letter, you provide it to your APN partner, which is basically your ISP, and ask them to establish the connection. And they will tell you how to configure the virtual interfaces so that that connection is established. We cannot do it all from the console. You can just only create a request. Your ISP will do that for you, right? Probably it will be over direct connect. That is a dedicated network connection to AWS. Right, in India, I think Sifi, Airtel, right? These guys are the providers, right? It depends on country to country, right? You have to contact them. Let's say probably create connection, right? All these things you have to provide, right? Service provider, you can see, right? Location is here, right? So again, depending upon the region, right? We are in which region? We are in Canada, so it is showing the locations in Canada. Okay, so I don't know the name, so I'm just choosing something, right? So the service provider there is this, so you can choose it like that, right? Okay, right, you see all others. See, in India you have Delhi, Hyderabad. If I choose here, who is my service provider? Tata Communications, right? So you have to create a request and submit it to Tata Communication. They will do, depending on which place you are, right? So it may not be available in all locations, but a lot of metro cities and countries, it should be available. That you have to just check whether it is available in your location or not, right? So this is like a direct a network connection to AWS, not over VPN, but like a through a physical link through your ISP or what they call the APN partner, right? That is also an option. This comes in the exam as a question, like you have a requirement where you transfer a lot of data and you need good bandwidth, good throughput for high traffic networks. Then what are you going to do? Are you going to they will give you four options, like a VPN connection or direct connect. The direct connect will be a better choice over there. You can establish VPN also, it will work, but the consistency and the throughput may not be as good as a direct connect. So if you have high bandwidth requirement, right, transferring a lot of data, and you need a consistent experience, the correct choice is going to be to choose AWS direct connect. That is to connect your on-premises to AWS location, and it depends upon the region where you are located. Okay, right? So these are some of the components of the VPC. So tomorrow we will go ahead, we will create the VPC as such, right? We will create the VPC and we will see how it works. Okay, so only if you start creating machines and you start seeing how the traffic is flowing, only then you will get the complete idea. For now, you can just read the VPC FAQs after the class. Like I said, after every class, even if you don't open the VPC user guide, fine, but at least open the VPC FAQ and just go through it, right? What is a VPC? What are the components of a VPC? Why should I use VPC? How to get started? What are the costs? What is IP addressing? Basic. This is what we saw, right? This is what we basically saw. You can just go through that. If you are interested in other things, you can read about the other things. What is peering connection and all those additional stuff, right? But just the first 3 or 4 topics, 3 or 4 questions, you can just read to revise whatever I have said. Okay, right? So let me know if you have any any questions.
No questions.
Okay, then we'll catch up tomorrow then at 8 o'clock. Right?
Okay, sure. Okay.
Sure.